In this video, I will show you how you can create a post-processor for your machine using an existing production file. In this demonstration video, I will be creating a post-processor for the shown Scorpio 1 robot using a production file for a pressure vessel. If we open the production file in a text editor, we can see that the file starts with some declarations and some initializations. After this, we can see that we start with defining the first layer and all the paths and movements in the layer. Now we will use the layout of this production file to reverse engineer a post-processor which is capable of writing this production file. This we will do by combining hard-coded code for the machine with meta commands used by TaniqWind Pro. These meta commands will write the design-specific variables like trajectories and design information to your production file. In the TaniqWind Pro software manual, a list with the allowed meta commands is shown. In this list, we can look up which meta commands are needed to write specific information. We can see that there are 5 categories of variables: general, product, layer, path, and production settings. We can also set formatting settings, use equations, and use repetition tags. In this text editor, I am using a special post-processor language which helps with visualizing the meta commands. Now we can start with the post-processor by copying everything until the start of the first layer. At the top we can see the name of the module and the software with the software version used to make this file. For the production of the module, we can set the name of the variable to product.name, and we can do the same for the software and the version variables. On this machine, we can set the actual offset as a variable on the machine itself. Therefore, we need to set the actual offset from the software to the machine's variable by changing the offset value to the product.actualOffset variable. Moving on to the main procedure. Here we can see some initialization for the machine and the setting of the robot configuration for the start and wind positions, which can be hard-coded since they do not change throughout the product. Now we arrived at the start of layer 1. Therefore, we should create a loop that writes all the following code for every layer. We can use the all layers repetition tag for this, which is shown in blue. With this repetition tag in, we can copy the part for every layer. We start by changing the layer name to the layer.name variable. After this, we can set the translation, rotation, and external axis values for the start position. For the translation, we need to set the x, y, and z coordinates with 3 decimal points. In the manual, we can find that for the x coordinate, we would need to use the path.x variable. We can also see the formatting setting we would need to write the variable with 3 decimals. Now we can copy and paste this part and change the path.x variable for the path.y and path.z variables. For the rotations, we need the 4 quaternions, which can be noted as path.q1 through path.q4. For the external axis on this robot, we need to set the track, mandrel and tool twist axis in the first 3 positions. We should also turn off the last 3 positions by entering the large number shown. With these set, we still have to add the actual offset to both the z-axis coordinate and the robot base. After this, we can move to the start position and give a user message to the operator. With this set, we can open an all paths repetition tag to consider all the paths in the layer. We can copy the for loop definition for the robot and change the number of loops to the variable path.endLoops. Now we can open the all moves repetition tag and paste the first movement description in there. We can change the number of the movement to the path.index variable, after which we can set the wind position arrays. These arrays use the same variable names as the start position, so we can copy those. After this, we can set the mandrel axis rotation position by changing the delta phi value for the delta phi variable. The last variable to set in the movement is the tape tension machine parameter. In this file, this is set in the move to position command, where we can see the value is now printed as 30. We need to change this to the machine.tapeTension variable and apply a rounding equation, since the machine needs integers for this input. Now we can close the all moves repetition tag and close the for loop we had running on the machine. After this, we can also close the all paths repetition tag. After this tag, we have a message we want to have at the end of every layer, so we can paste it from the production program into the post-processor. With this message in, we can also close the all layers repetition tag, after which we can end the procedure and the module. With the post-processor finished, we can copy it and paste it in the code panel for the machine in TaniqWind Pro. With the post-processor in the code panel, we can parse it to check for mistakes in the use of meta commands. Another option in TaniqWind Pro is to create different files for every layer or path in the product. These files could be called in on the machine when needed. This can keep the created files shorter and could make it easier to look certain things up in the files. I will now show you how you can convert the post-processor we've just made to such a setup. For this, I will again use an existing pressure vessel production file for this robot. We can see that we have one file where we call in the layer files, and we have a file for a layer where we can see that we initialize the robot and print all the movements for all of the paths in the layer. I will start by copying the entire file from the product level. We can see that the first lines are equal to the previous post-processor, so we can copy these from there. After this, we need to print the names of the layer files, which we can do with the all layers repetition tag. We will give the files of the layers the name of layer with their layer count. Therefore, we print the name as layer with the layer.count variable. After this, we can close the all layers repetition tag and end the procedure and the module. If we now move to the layer file, we can see that we start with the name of the module and the procedure. After this, we can copy the layer initialization part from the previously made post-processor. With this part in, we can copy the all paths and all moves repetition tags. We only need to set them to the right indent level, after which we can end the procedure and the module. Now we can copy these files to the post-processor in TaniqWind Pro and parse them to check for errors. With the files parsed, the post-processor can be used for generation of production files. This is the end of the TaniqWind Pro post-processor demonstration video, where I've demonstrated how to write your own post-processor for TaniqWind Pro based on an existing production file. If you're interested in other highlighted feature videos, these can be found at the Taniq YouTube channel.